Dilated line equation also pretty much always on the Regents exam, all right, and they're pretty straightforward. So there's two cases. If it's centered at the origin, you find the slope, all right, you multiply the y-intercept by the scale factor and create your new equation, all right? And basically the only thing that's going to change is the y-intercept. So I'm going to write down only y-intercept changes, all right, because you're going to do that right there. Okay, there's no need to use a graph for one of these things, all right? I'm going to write down solve for y. All right, whoever made this little thing, that's what they mean by this first thing right here. All right, solve that for y. And then you just take the, so if you can see what we got here, there's the y-intercept, all right, -4, and you multiply that by the scale factor that they give you in the equation, and then you get your new equation, all right? If it's not centered at the origin, all right, you basically just check to see if the point is on the line. Basically, I can tell you that without fail, it's going to be on the line, okay? And if the point's on the line, that means that the line doesn't change at all, because if you dilate it from a point on the line, it doesn't move. It's like if you reflect it and it's on the line, it doesn't move, okay? So that's all we're really doing, all right? So the new line will always be parallel and kind of, I mean, this line right here stays the same, so it's not really parallel because it's the same line, all right? But the slope won't change is what this person is trying to get through that made this here, all right? The slope will not change ever, all right? The y-intercept will change when it's centered at the origin, all right? When it's not centered at the origin, it is basically almost completely impossible that it'll change. It could, all right? But in the rare situation that happens, just kind of use common sense and move it, dilate it from that point.